This is Mr. Martin. This is the video for section 6.3, Vectors in a Plane, day 2. This is video 2 of 2. We didn't have time to quite finish this last problem. So the last problem for the examples, we're looking at a composition. So there's a lot of important concepts in here. And again, the vocabulary in this section is really important because if you don't understand the vocabulary, you won't be able to answer the questions or know what the questions are asking for. So we have an airplane flying in a direction of 50 degrees with an airspeed of 300 miles per hour. Okay, if there is no wind, the course of the airplane would be 50 degrees. Now, you have to be careful here because if you notice the 50 degrees is off of what would typically become north. So this is north 50 degrees east. But if we're talking about direction angles, it's really going to be 40 degrees for our direction angle. Alright, however, there is a 35 mile per hour wind from the direction of 120. So again, if you notice the way this angle is measured, it's 120 here. So what we're going to need to do is we're going to need to find this angle over here. Alright, I know that this whole angle over here is 180. And if this part is 120, that means that we've got to have 60 left over here, so that this angle over here is going to have to be 150. So this angle here is 150. Again, if you have questions, make sure you ask. So we've got two direction angles. We have one for the airplane, we have one for the wind. And you have to kind of interpret those from the given information. So we've got the vectors P and W, which show the angles used in aerial navigation, okay? And we just converted those into our direction angles that we'll need for our calculations. Find the course and ground speed of the plane. So the course, you have to interpret this as the direction angle and the ground speed, you need to interpret this as the magnitude. Alright, so we want the magnitude and the direction angle of what we call the resultant. Okay, so we're going to find the resultant, vector, and once we do that, we're going to find the magnitude and the direction of the resultant. So find the resultant vector, then find its magnitude and direction. Okay, so you know the expectation is that you're going to be able to interpret all of that from the information. Alright, so this is a multi-step problem. First we have to find the resultant. So basically this is adding some vectors. Adding vectors. Okay, so what I'm going to do first is I'm going to put these two vectors in component form the way we did in the first couple examples. So I've got P is going to be, and my magnitude of the plane is 300 miles per hour, and the direction angle is 40, so that's 300 cosine 40 and 300 sine 40. Alright, and these are not special angles, so we're just going to plug them into our calculator. Make sure you're in the right mode. So I have 229.81 for my x component and 192.84 for my y component. Then I'm going to do the same thing for the wind. I'm going to find the component form for the wind. So it had a magnitude of 35 and a direction angle of 150. So it's 35 cosine 150 and 35 sine 150. So that gives us negative 30.31 and 17.5. Okay, and that would make sense because we see that this vector is in the second quadrant, so it should have a negative x component. So then if I do p plus w, I'm simply going to add these together, and then I'm going to add these together to get the x and y components of the resultant. Okay, pay particular attention to the vocabulary I'm using. So the resultant is the sum of the component forms of the plane and the wind. So for the x component, we should get 199.5, and for the y component, we should get 210.34. So this is the component form of the resultant. Okay, so this would be the path of the plane with the wind taken into account. Alright, so now that we've done that, we need to find the speed. So the speed is going to be the magnitude of the resultant, so p plus w. So that's going to be the square root of 199.5 squared plus 210.34 squared. And that should be about 289.9 miles per hour. So you can see that it slows the plane down a bit. And we also need to find, next we're going to find the direction for the resultant. So the direction, and this is going to be our theta p plus w. So that's going to be the tan inverse of 210.34 divided by 199.5. And our original vector was in the first quadrant, and we're just adding this little bit to it over here. So we should still be in the first quadrant. Right, here's our resultant, this big vector right here. And if we calculate that, we should get about 46.52 degrees. So here is the speed, or the magnitude of the resultant. Here's the new direction. You notice it was at 40 degrees, and the wind has pushed it a little bit over to 46.52. So again, some very important concepts in the problems that we've done in this video, or in the last two videos. So if you have any questions, make sure that you're asking those and getting those answered, and make sure you're doing plenty of practice problems so that you know how to do these for the quizzes and tests. We'll see you next time.